Welcome to non-right angle triangles and using sine law, everyone. Oh, and thank you for showing up for your learning. I appreciate it, everyone. I appreciate everyone showing up from the beginning right to the end. Just wonderful working with students that show up hungry for knowledge. You know, when you come in, just like waiting to receive all this knowledge and then apply it in your own practice, it really makes working with you a pleasure. So let's take a look at when we have triangles that don't have right angles. Okay, so if we don't have a right angle, we cannot use SOHCAHTOA or the Pythagorean theorem. They don't work when we don't have right angles. Using them is not right. It's not right to use those. So you have to use sine law or cosine law in those cases. Welcome back. We're just starting. Okay. So on your handout, I've shown you sine A equals over A equals sine B over B equals sine C over C. This is sine law. We proved it here. Okay. And now we're going to use this to solve some problems. But I want you to write this upside down as well. What do you mean by writing it upside down? I want you to notice something. If I tell you 2 equals x, then 1/2 equals 1 over x. That's just a fact of numbers. I can always flip both sides of an equation. It's a really fancy inverse operation you can do to both sides. Just flip both sides. Okay? The only time you can't do that is if one of your sides is equal to 0, because then when you flip, you're going to get a 0 on the bottom. We don't like that. Okay, so don't do that, because then the universe creates a sinkhole and we all fall through it. And we've all had that happen to us at least several times a week. So write it upside down as well. What do I mean? It looks like this. A over sine A is equal to B over sine B is equal to C over sine C. And I'm realizing my tablet is a little bit rotated. There we go. That's better. So now this is the way we label our triangles. The A, the big letter A, corresponds to this angle. The little letter A corresponds to this opposite side. Okay? And when we write it down this way, we're writing the law this way, and we're writing the law that way in the flipped form. Get used to choosing one of those forms, and it helps you avoid making unnecessary algebraic manipulations when using the other one would be simpler. And I'll show you that as we go. Okay, let's go, people. So example, solving a side length. So I am going to do this example, and as I do this example, you copy down the solution. With the second example that's also on your page, you're going to start that, and then we're going to do it together. So here we go. We have been asked to solve side B. Well, which one is side B? Well, here is big letter B, that's the angle B, and it goes across to side B here. Let's just see, maybe we've got a 90-degree angle there. How could I check? Yeah, let's find angle C just for fun. And if it's 90 degrees, then we can just use tangent, because if that's 90 degrees, this would be the opposite. This would be the adjacent. We just use tangent to find it. So angle C plus angle 73 plus 42, that should be 180. Thanks, Jake. And now when we evaluate that, C is most definitely not equal to 90. Okay, that's all the information we need to know we can't use a natural trig ratio. We have to use sine law or cosine law. So when we notice, this is what we're looking for to see, can I use sine law? To use sine law, I need one of these related sides and angles. When I have this, then I will use sine law. When I don't, I will need cosine law, and I need to show up to class on Tuesday and learn cosine law. Okay? But for now, this is the question type that we can't answer. So what we want to set up is a relationship between angle B and side B and angle A and side A. And because I want to solve for a side, I am going to use this form of the sine law, where my unknowns are on the top. Put your unknowns on the top, and it is easier. Okay, let's go. So I'm going to write it down. A over sine A, and you're going to write this too, A over sine A is equal to B over sine B. I only need two of these ratios to solve it. I don't need C over sine C over here, because I've not been asked to find side C. To do that, I would need to find angle C first anyway. All I know right now is it's not 90. Okay, So now let's put in our unknowns here, our knowns and our unknowns. So A is 23, and that's over sine of 42. And that's equal to B is my unknown over sine B, and B is 42. Why did I write down that over there? Oh my goodness. Sine of 42. I said 42 when I meant to say was sine of A. Here is A, 73 degrees. So you're going to put 73 degrees over here. Okay? Now, how do I isolate B? How do I isolate B, everybody? Who knows how I can get B alone in this equation? How do I get B on its own? Yeah, I can multiply. And what am I going to multiply by? Sine 42. Okay. When I multiply both sides by sine 42, it will cancel top and bottom there and leave me just B. So B is equal to sine 42 times 23 divided by sine 73. And that's what I can punch on my calculator right here. So sine 42 times 23, and this is what it looks like when I punch this on my calculator. Get my calculator going, move it over out of the way of what I'm calculating. I want to find B, that was what I was asked to find. So I write down the sine of 42, there it is there, this wacky number, multiplied by 23, divided by sine of 73. That's the sine of 73. Then I push equals. It tells me that side is 16.09 long. So 16 long is just fine. Side B is equal to 16 meters.
So you did sine 42 times 23 and then divided by sine 43?
Yes. Okay. Yeah. So then we go over to Fisher. What's your question, Fisher?
You're not sharing your screen.
Oh, thank you very much.
No,
okay.
You were supposed to, sorry.
Yeah, I was definitely supposed to. Thank you for letting me know. So I don't know why I turned that off. Oh, I did attendance, and then I forgot to turn it back on again. I should set an alarm on my phone or something. I just forget that far too often. Okay, so if I want to solve for this one, you need to first find these pairs of knowns that create one of your ratios. Because A and side A over here, this is little side A, this is little side C. We weren't asked to find little side C, we were asked to find little side B. So that would be 16 meters here. Why is it 16 meters? Because B divided by its sine, B divided by sine 42, has to equal 23 divided by sine 73. To isolate B, you just multiply both sides by sine 42 and it comes over there. And then you find it. Therefore, B is equal to 16 meters. Does that look reasonable? That this side would be 23 meters? This side would be a little bit shorter than that, but not by half? Hannah?
Yes. But is there a hypotenuse or is that only with right angles?
We only talk about hypotenuse when there's right angles. Yeah. So sine is just a tool now that we're using to break down these problems. When I drop this x, then there's the hypotenuse. Then this would be a hypotenuse for this triangle, and this would be a hypotenuse for that triangle, and so on. But they're not strictly speaking called the hypotenuse. Certainly not in this triangle.
Yeah, that's what I thought.
All right, so let me get you started on this next problem. What I'd like you to do is to work on this problem to solve side C. So let's see, which side is side C here? Let's make sure everyone is solving for the same thing. Is this side C or is this side C? Yeah, this one here. This is little side C. You want to solve for that. What's this angle here? I need angle C if I'm going to solve for a little c. What's angle C over here?
99.
So this is angle 99. This is angle 43. 38, did you say? Sounds good. Let's see. Angle C plus angle A plus angle B should equal 180. Okay, so let's put that in. 43 plus 99 gives me 142. 180 minus 142, indeed. C equals 38. Okay, I'm going to pause the video there, but I'm going to give you 2 minutes to work on that one, and then we'll take it up together. So who's got the answer? All right, so let's take a look. We'll do this one together. Is 7.5? Is it? I don't know. Let's do it. 7.5. We'll put question mark. It was probably right. Okay, let's evaluate. It looks reasonable, right? If this is 12, we'd expect that to be around 7.5. Looks good. Okay, let's evaluate. The first thing we had to do, who had this? 12 and 99. You guys see that? Great. It's this opposite pair of information. It means we're allowed to use sine law. Because we don't have a 90-degree angle, we can't use straight up trig. We've got to use sine law or cosine law. So we can use sine law here. It's much simpler than cosine law. And we're solving for a side. So let's put 12 on top and sine 99, that's cool, sine 99 on the bottom. That's going to be equal to c over sine c. So c is our unknown. Put it on top. Has to match here, though. If I have length on top, I have to have length on top over there. I can't flip one side and not the other. That would be does not compute. Won't work. Okay. C over sine 38. Okay? Because we calculated that angle C was 38 degrees. Okay? Now, we multiply both sides by sine 38. And I might write that as 12 sine 38, like that. That would be fine. And then these cancel. So that isolates C. That's great. This is C. Let's find out what it is. 12 multiplied by the sine of 38. This calculator is like yours, where I have to put in 38 first and then push sine. All divided by sine 99. See, sine 99 is just so very close to 1. Equals 7.45.
I got the two numbers right, but I got the answer wrong.
Well,
Maybe it's set in radians. I'll fix it for you in a minute.
Like, I got 0.61, and then I got 0.98. But how do I got it?
I'll take a look in a minute, Hannah. I think the calculator is probably set to radians. You can bring it up. All right, now let's take a look at this word problem. Huh? Oh, then I'll help you later.
Okay, should I use a Google one?
You should go on your phone. Yeah, that's fine. Okay, so now let's do this question here. Oh, so just taking another look at this for those that weren't able to get it. C is equal to 12 times sine 38 over sine 99. We started with C over A over sine A. Oh, sorry, B over sine B is equal to C over sine C. And then just multiply both sides by sine C to isolate C. Now, when we've got a word problem, what's our first step? Huh? Draw a picture. Great. A post is supported by 2 wires, one on each side going in opposite directions, creating an angle of 80 degrees between the wires. So I'm going to draw the wires here. Here we go. Here we go. Call that 80 degrees. Okay. And the ends of the wires are 12 meters apart on the ground. Here's the ground. My pole's in the middle. I'm not going to draw it. I don't know how tall the pole is, and so I don't really care about the pole. But I know that the angle between the wires is 80 degrees, that along here this is 12 meters along the ground, and one wire forms an angle of 40 degrees with the ground. We want to find the lengths of the wires. So let's go for it. So this one here, this one could be 40 degrees, sure. All right, so now we've got all of our knowns on there. Let's go ahead, we'll find this angle first. What's this angle over here?
That is 60.
60 degrees, because 60 plus 40 is 100, 100 plus 80 is 180. So that is indeed a 60-degree angle. Was not given by the problem, but we can calculate it with the angles of a triangle adding to 180. Super duper. And we want to find, let's label this side, side A and this side B. Okay. And now, let's set it up.
Is it okay if I did that?
You called the different one A and B? Oh, that's fine. I could call them...
B is the
I could call this one A for Ashley and this one J for Johnny if I want to have a Johnny wire and an Ashley wire.
Okay, so it doesn't like.
It's
Sine
arbitrary.
A and stuff doesn't matter. It's just sine
Yeah.
and then okay.
I could call this side Ren and this side, I don't know, Qi. Okay. Yeah, but I'm not going to call them Chinese characters because that'll confuse people. And my Chinese characters are very out of practice. So I choose letters. Totally arbitrary. You call them what you want. Okay. So now I've got all my knowns written down, and this was even an unknown. We calculated for that. Good job. And then nostrils. Alex? Nose. Alex? Nose. So A's and B's we want to find. So let's find A. A over, and then what I do is I look at this and I say, where is my opposite pair of information? 60 goes with A, 40 degrees goes with B, and then I have one pair of knowns here, 12 and 80, okay? So I'm going to use those to answer this question. A over sine 60. This is one pair equals, and let's do it in another color. This one is B over, or C over sine 80. So that's 12 over sine 80. Okay. Now to solve this one for A, I'll multiply both sides by sine 60. Because I'm dividing here, multiplication moves it up to the top on the other side. Cool. Now I have A is equal to 12 sine 60 over sine 80. And then we evaluate. Solve that one for A. Clear everything. A is 12 times sine of 60. And then I move my face to get out of the way. That's the value of sine 60. Very close to 1. It's very close to 87% or so. And actually, it's the square root of 3 over 2, but you don't need to worry about exact values until next year. Okay, and then I'm going to divide that. That's the value of 12 times sine 60 on top, 10.4, divided by, I already have in my calculator, the sine of 80. That's the sine of 80, very close to 1. So then I push equals, and it tells me that's 10.55. Okay? And that would be in meters because I have 12 meters already in the problem. So we have found that this one here, side A, this is equal to 10.5, 10.6 meters because it's 10.55, so that rounds up. Now let's find side B. Okay? So sine B, big B over here, this is big B. This is big A, and this was big C. Okay. Now, we could use either pair of knowns and unknowns, but I would prefer to work with the knowns that we were given. So I'm going to use those. We'll work in blue. So I was given these, so I'm going to continue working with those. 12 over sine 80. I'm going to give myself some space for my inverse operations is equal to a B over sine 40. What do I need to multiply by to isolate B? Multiply both sides by sine 40. Cancels. Sine 40 up here. Multiply both sides. Sine 40. So B is equal to 12 times sine 40 over sine 80. And that's what you're going to tend to have when you're solving for unknown sides, is the known side divided by the known angles sine multiplied by your unknown side's angles sine. There. That's how it shakes out when you're solving these. So let's solve it. When you punch it on your calculator, it should look like this. 12 times, what do I have there? Yeah, sine 40. I don't know why I can't grab that. There it is. 12 times sine of 40. I don't happen to know sine 40 offhand. There it is. Divided by sine of 80, which we saw was very close to 1. So it doesn't change that number very much. Very close to 1. That is equal to 7.83. So we would say 8 or 7.8. Yeah. What? Did it give you a negative number?
Yeah, I did cos sine 40 divided by sine 80.
Are you working on Google?
Yeah.
It's probably in radians.
Oh, wait. Yeah, you're right.
B is equal to 7 point, I said 7.8? Yeah, 7.8.
Okay.
So there, B is 7.8. So the B wire was 7.8 meters long, and the A wire was 10.6 meters long. We can solve these types of questions with trigonometry now, even though there's not a right angle to be seen. Now, here are some practice problems for you to do. I will just go ahead and write those on the board so that you can see them. And I think it's about time for us to have our break, isn't it? What time do we go on break? It's right at 1? Okay. Do you want some time to work on some practice problems, or do you want me to do the next lesson? Next lesson much shorter. It's just solving for sides. Sorry, solving for angles. Is it break? No, it'll be break in 10 minutes.
Is the lesson 10 minutes?
Yeah. Do the lesson? 402. Numbers 1, 2, 9, 12, 13, 14. Okay. So let's go on. We're going to keep going. Now we're going to use sine law to solve non-right angle triangles and to solve the measures of angles. Okay? Yeah. So now we're going to do some more questions here. So now if I am given two sides here, but I'm not given this side, sorry, this angle, and I want to solve for that angle, now what I'm going to do is write my sine law upside down so that I have my angles on top. And that's going to make it easier to solve. So in this case, I notice I have this information that's in this opposite pair of angle and side, and I can say the sine of 39 degrees divided by 28, well, that will be the same thing as the sine of r divided by 41. Notice that I have this pair here of side and angle with one unknown in it, the unknown angle. I can use this known side to find it. How would I do that? What do I need to do to isolate sine r here? Great. Multiply both sides by 41. 41 times sine 39 over 28 is equal to sine r, because these cancel. Great. So now let's find out what sine r is, and we're going to get a decimal approximation, and I'm going to keep 4 decimal places for accuracy. So 41 divided by 28 multiplied by sine 39. Let's do that. Clear everything. 41 times the sine of 39 equals 25.8 divided by 28. Now there is a funky thing that can happen here where it gives you a number back that's bigger than 1.
I got like
54? Oh, then you punched something wrong. In this case, you punched something wrong. But it is possible to get a number back here that's bigger than 1. In that case, it's not possible to make a triangle that matches your diagram, because it's not possible to have a value of sine that's 1 or bigger. Well, it is possible to have a sine value that's 1, but not bigger than 1. So here we go. This is the value of sine r. It's 0.925. What was it? 0.925. 9215. Sorry? Yeah, 9215. There we go. That's equal to sine r. So now, what inverse operation allows me to solve for this angle?
bring it over, right? You divide it.
I use the inverse sign here. So the inverse sign, taking the inverse sign of both sides, what I would write is sine inverse of 0.9215 is equal to r. Okay? This is what gets punched on my calculator. Now what that is saying is, given that this angle r, its sine is equal to that, find me angle r. That's what that is telling you. And so where do you find this sine inverse? It's usually the second function of your sine button on your calculator. So let's go ahead and punch that. We're expecting an answer that's in angles, or that's in degrees. And just looking at this, it looks like it's going to be an angle that's bigger than 39 degrees. Should be bigger than 39 degrees because 41 is a lot bigger than 28. So I'm expecting an angle like maybe 53 or something like that. Let's go ahead and take a look. Here is this number, 0.9215. And then I go ahead and take the sine, see, I go second function, sine inverse of that. Tells me 67 degrees. So my guess of 53 degrees was not absolutely horrible, but it was pretty junk. I could do a lot better with my guess next time. So 67 degrees. There we go. That's R. So accurate to 1 degree should be fine. So R equals 67 degrees. Done. Final answer.
And sorry, just a question.
Yep.
Did you times sine minus 1 by 0.9215?
No, sine inverse. The way we read this here is sine inverse.
That is sine.
That is saying, given that some angle produces a sine of 0.9215, find me that angle. That's what sine inverse is. It's the opposite of saying take the sine of that angle.
So like in the calculator, do you just press like sine inverse, then do that number, and then it equals?
Yes, you just push sine inverse and then this number. Or depending on your calculator, some calculators want you to push sine and then type in the angles, or they want you to type the angles and then push sine. You need to know your calculator and what order to push the buttons.
Sure.
And that's one of the reasons why I do lots of practice problems, is to learn your calculators. I get confused by new calculators all the time. Then I learn them in like
I lost mine.
1,
I
2.
had to get a new one while we were online.
It's like working with a bionic arm. You know, it's a new model, but I like the biological one better.
Mr. Is that 67 or 6.7? Because there's a little.
67.
Oh, 60.
I don't know where that point came from.
I
Okay,
accidentally
67
put,
degrees.
sine 28. That's why I got like 54 or whatever.
Okay. Problem. Okay, what do we do? What's our first step? My first step looks like this. I'll show you my first step.
Good afternoon, CCI. Please pardon this interruption. Very shortly, we are going to arrive at everybody's classroom door with a package for the students that are to be distributed to the students before the students leave today. And we're asking teachers to take